Common rocks forming minerals. What is minerals? Minerals are naturally occurring substance which is usually solid, crystalline, stable at room temperature, and inorganic. Minerals themselves are made up of one or a number of chemical elements with a definite chemical composition. Minerals cannot be broken down into smaller units with different chemical compositions in the way that rocks can. Minerals are the building blocks of rocks. A crystalline substance displays a specific, repeated, and three-dimensional structure at the molecular level. In some cases, the crystalline molecular nature is visible only with the use of microscope, but minerals sometimes form actual crystals, which are geometric forms visible to the aided eye and consisting of smooth faces and sharp edges. Physical properties of minerals. There are several different mineral properties which must be identified and defined. These 7 physical properties of minerals include luster, hardness, crystal form or habit, color, streak, cleavage, and specific gravity. So let's first talk about luster. It refers to how light is reflected from the surface of mineral. There are 2 types of luster. First is the metallic luster and the second one is the non-metallic luster. Metallic luster is generally opaque and exhibits a resplendent shine similar to a polished metal. Minerals exhibiting metallic luster look like a metal, such as silvery appearance or that of a flat piece of steel. While non-metallic luster includes viscous or glassy, adamantine or brilliant diamond-like, resinous, silky, pearly, dull or earthy, and greasy among others. Next physical properties is hardness. Hardness is the ability of the mineral to resist scratching. Friedrich Mohn, a German mineralogist, develops a hardness scale over 100 years ago. The hardest mineral known is diamond and was assigned a number 10. It is called the most hardness scale and it ranks the order of hardness of minerals and some common objects. Next is crystal form or habit. It refers to the characteristic shape of a mineral unit. Crystal form. The form reflects the supposedly internal structure of atoms and ions of the crystal or mineral. It is the natural shape of the mineral before the development of any cleavage or fracture. A mineral that do not have a crystal structure is described as amorphous mineral. Next, color. Color is one of the obvious characteristics of mineral, but generally not the most useful diagnostic feature. Minerals are colored because certain wavelengths of light are absorbed, and the color results from the combination of those wavelengths that reach the eye. Next, streak. Streak is the mineral's color in powdered form. It can be useful for identifying metallic and earthy minerals. Non-metallic minerals usually give a white streak because they are very light colored. Other minerals may have very distinctive streaks. An example for this is hematite. Hematite always gives a reddish-brown streak no matter what type of luster it displays. Next one is cleavage. Cleavage is the ability of the mineral to break along preferred planes. The number of cleavage planes in a mineral may also aid its identification. In mineral, cleavage typically occurs in either 1, 2, 3, 4, or 6 directions. Last physical properties of a mineral is the specific gravity. It is the heaviness of the mineral. It is defined as the number that expresses the ratio between the weight of the mineral and the weight of an equal volume of water. Water has a specific gravity of 1. Okay, now that we have discussed the 7 features or the 7 physical properties of mineral, let's proceed now to the chemical properties of minerals. Every substance on Earth is made of atoms, the building block of all matter. There are all different types of atoms and each type of atom is classified as an element. Atoms will bond together to form molecules, which are organized agglomerations of different types of atoms. Mixtures are groups of molecules that can be separated by physical means. Compounds are groups of molecules with a definite arrangement and can only be separated by chemical means. Every mineral contains a defined ratio of specific molecules in its structure. Here are common rock-forming minerals with their physical and chemical properties. First, we have quartz. Quartz is a pure or nearly pure silica and it is a hard and glassy mineral. It is transparent to translucent in nature and its colors varies from white to gray to smoky. It does not have a cleavage, thus it does not break into regular flat faces. Quartz hardness is 7 and a specific gravity of 2.66. Next is feldspar. Feldspar is a silicate of alumina with alkaline substances like potassium, sodium, and calcium. Its appearance is not so glassy as that of quartz and is dull to opaque with a porcelain-like appearance. A stone readily meets the decay if it contains large proportion of feldspar mixed with other minerals. Feldspar hardness is 6 and has a specific gravity ranging from 2.5 to 2.7. Next, hornblende. Hornblende is a complex silicate with a hardness scale of 5.5 and a specific gravity of 3.2. Hornblende is a dark-colored mineral found in many types of igneous and metamorphic rocks. Next, we have calcite. Calcite is a leading constituent of limestone and marble. Calcite hardness is 3 and has a specific gravity of 2.7. Dolomite. Dolomite is a magnesium carbonate with a chemical composition of CaMgCO3-2. Metamorphic rocks like dolomitic marble and pure sedimentary rocks have dolomite as the major constituent. Dolomite has 3 directions of a perfect cleavage. Its hardness ranges from 3.5 to 4 and has a specific gravity ranging from 2.8 to 2.9. Last, we have mica. Mica contains silicates of aluminum with potassium. It is soft and readily affected by atmosphere and chemicals. It has a perfect cleavage, causing it to easily break into thin sheets. Mica's hardness is 2.5 and a specific gravity of 3. Those common rock-forming minerals fall to a certain mineral groups. So what are these mineral groups? First is silicates. Mineral group silicates are minerals containing 2 of the most abundant elements in the Earth's crust, namely the silicon and oxygen. When silicon and oxygen link together, they form silicon-oxygen tetrahedron. the fundamental building block of silicate minerals. Over 90% of rock-forming minerals belong to this group. Aside from silicon and oxygen, other most common elements that make up the Earth's crust are aluminum, iron, calcium, magnesium, sodium, and potassium. Next mineral groups are the oxides. Oxides are minerals containing oxygen and iron, combined with one or more metal ions. Oxides are commonly known as rust, or things that attach to a metal when they get oxidized. Third mineral groups are the sulfates. Sulfates are minerals containing sulfur and oxygen and iron, combined with other ions. Sulfates are good for cleaning and cleansing detergent. Sulfates are found most common in cleaning detergent and even shampoo. Next mineral group are the sulfides. Sulfides are minerals containing sulfur and iron combined with one or more ions. Some sulfides are sources of economically important metals such as copper, lead, and zinc. Sulfides are a good conductor and are used in thermoelectronic devices. Next mineral group is the carbonate. Carbonates are minerals containing the carbonate and ion combined with other elements. Carbonates are used in the development of drug, pulp or paper making industry and in some making of glass. Last mineral groups are the halides. Halides are minerals containing halogen elements combined with one or more elements. Some halides are used in metal halide lamps that are high-intensity lamps.